morning, fellas. Welcome to the another episode of Super Revision YouTube live series powered by Excel Educational Center. I know that you people are well worried as the days are getting less come down, right? But don't worry, people. Believe in yourself and make the final revision better. Today, here, I'm going to explain the content, relations, and functions for you. Okay? After my class, my mentor, Fail Rahman, will be talking about differential equations. Okay? Fine, here we go. Question number 1. But before getting to that, let me ask you one thing. Tell me the different things you are learning in the chapter Relations and Functions. Number 1, types of relation, where you will be learning about reflexive relation, symmetric relation, transitive relation. And the second thing is that types of functions, where you will be learning injective function, surjective function, one-one function or on-two function. And the final thing, that is composition of functions and invertibility of functions. Alright, so here let me start with the first question about equivalence relation, that is reflexive, symmetric and transitivity. Question number 1. Let L be the set of all lines in the xy plane and R be the relation that is defined on that set L, defined as two lines L1 and L2 are related to each other if L1 is parallel to L2. Show that the relation R is an equivalence relation. Find the set of all lines related to the line y is equal to 2x plus 4. People, tell me what is the rule for showing that a relation is equivalence. For saying a relation is equivalence, it must be reflexive, it must be symmetric, it must be transitive. So guys, please tell me what is the rule of reflexivity, symmetricity and transitivity. The rule of reflexivity is that you have to focus on the set where the relation is being defined. If the set contains an element A, then the relation must contain the reflexive pair, that is A comma A, which should be satisfied for every element in the set A. For example, see, I'm having a relation that is defined on set A, which contains set of 1, 2, 3. Then the relation must need to contain the pairs. What are the pairs? 1, 1, 2, 2, 3, 3. So say that the reflexive pair of each element should be there in the relation. Now imagine the scenario where 3 is there in the set, but 3, 3 is not there in the relation R. We can call the relation as reflexive? No. That is why this term, that is for every A belongs to A, for every element in the set A, this condition should be satisfied, is well mentioned in the condition of reflexivity. Clear the point? Fine. Now the next one is symmetricity and transitivity. See, if you are checking reflexivity, you have to focus on the set. If the set contains this, then the relation contains this. That is so. But if you are focusing on symmetricity and transitivity, remember that you don't need to check on the set, but instead you have to focus on the relation. If the relation is containing A comma B, then the same relation must need to contain which one also? B comma A also. If the relation contains A comma B and something starting with B, B comma C, then the relation must need to contain A comma C. This is a rule for transitivity. I repeat, if A comma B, B is a pair on the relation. If this happens, if this element is there in the relation, then in symmetric pair, that is B comma A, should be also there in the relation, for calling the relation as symmetric. Similarly, if I'm saying that A comma B and starting with B comma C are there in the relation, if these two people are there in the relation, then the transitive pair, that is A comma C, should be also there in the relation. Then only we can say that the relation is symmetric and transitive. And this should need to be satisfied for every A, B, C belongs to the set A. This is the rule, people. Now, let me show you the questions associated with that. Question number 1. Let L be the set of lines in the xy plane such that relation R is equal to. Well, in every question there exists two parameters. Number one, what is a set where this relation is defined? Let me call the set as L. Let L be the set of all lines. The set of all lines. People, tell me what are the elements in this line. You can see number of lines here. Line like this, like this, like this, like this. First one you can call L1, second one L2, L3, L4, L5, etc. So in general, I can say that this set contains, what are the elements? L1, L2, L3, L4, etc. as their elements. Okay. Now tell me what is the relation. Number two, relation R defined as L1 comma L2. L1 is related to L2 if, what is the rule? L1 is parallel to L2. This is the rule. So, identifying what exactly is the relation, identifying what exactly is the set where the relation is being defined is a prerequisite knowledge you must need to know before answering or before checking reflexivity, symmetricity and transitivity. Here we go, people. Number one, reflexivity. Tell me whether this relation is reflexive or not. What is the rule of reflexivity? If the set contains an element A, then the relation must need to contain A comma A. Here, the set contains L1. Then the relation must need to contain L1 comma L1. People, whether L1 comma L1 will be there in the relation? L1 comma L2. In order to happen L1 comma L2 in the relation R, L1 should be parallel to L2. Yes or no? Yes. Then my question is that L1 comma L1 will be there. Whether a line is parallel to itself? Yes. Every line is parallel to itself. In that case, I can say that if L1 is an element of set A, then L1 comma L1 should be always an element in the relation R. This happens for every L1 in the set A. Therefore, I can say that the relation is reflexive. Well, why L1 comma L2 there in the relation R? Because you had to justify your point. What is that? Every line is parallel to itself. Writing this justification is something very important, especially if the question is a 3-mark question. Okay, you need to write the justification why L1 comma L1 is there in the relation. Now, whether the relation is symmetric, in order to check symmetricity, you have to check this rule. If L1 comma L2 is there in the relation R, then tell me whether L2 comma L1 is there in the relation or not. People, L1 comma L2 there in the relation, it means that, what is the meaning of that, people? Tell me what is the meaning of that. It means that L1 and L2 are parallel. Two lines are parallel. That is the meaning of that. Now, conversely speaking, whether L2 is parallel to L1? Yes. That's why L2 comma L1 is also belonging to the same relation. This happens for any pairs. For any pair L3 comma L4 is there in the relation of, then L4 comma L3 is also there. Such a way that if you take any pair, the condition of symmetricity is being always satisfied. Therefore, I can say that the relation is symmetric. To the point. Now tell me the rule of transitivity. For defining transitivity, you must need to deal with 3 lines. The 3 lines. What are the 3 lines, guys? Tell me. The 3 lines are L1, L2, L3. Such a way that if I'm saying that L1 comma L2 and L2 comma L3, if these two pairs, what are the pairs? A comma B and B comma C, something starting with same thing. L2, then L2 comma L3. If these two guys are there in the relation R, then tell me the transitive pair, that is L1 comma L3, is there in the relation or not. People, L1 comma L2 is there in the relation. What is the meaning of that? What is the meaning of that? The meaning is that, wait, let me change the color. L1 comma L2 is there in the relation, which means that L1 is parallel to L2. Okay. Now L2 comma L3 is there in the relation, which means that L2 is parallel to L3, which means all the three lines are parallel. In that way, I can say that L1 and L3 are also parallel, or L1 comma L3 is there in the relation. Therefore, I can say that this relation is transitive. Such a way that you can define reflexivity, symmetricity, and transitivity, and hence I can say that this relation is an equivalence relation. By the way, if you found this relation is reflexive, symmetric, but not transitive, any of the one criteria among the three is not satisfied, then can you call this relation equivalence? No. You cannot call equivalence if any of the one of the criteria is being not satisfied. If all the three is attained, if the criteria of reflexivity, symmetricity, and transitivity is being satisfied, in that case I can say the relation is equivalence. Got the point? Fine. Now there is one simple part. Find the set of all lines related to the line y is equal to 2x plus 4. People, tell me what are the lines L1 related to L2. The lines that are related to L1 are L2, right? If L1 is parallel to L2. What is that? Two lines will be related as per this relation if, what is the rule? They should be having, they should be parallel. Or another way, they should be having the same slope. Yes or no? Yes. So, the set of lines related to with this line will be those lines that are parallel to this line. Yes or no? If I am saying that I am having a line, such a way that this line is parallel to y equal to x plus 4. So obviously I can say that these two people will be related to each other. Yes or no? Yes, because they are parallel. Now, if two lines are parallel means they are having what? Same slope. Here, the slope of the line, this is of the kind y equal to mx plus c, where m is equal to 2, which means that the slope is equal to 2. So we can say that the set of all lines, the family of all lines whose slope is equal to 2, are those lines that are related to the line L1. To the line y is equal to 2x plus 4. People remember, in this case, I can define this as the main line y is equal to the main line that is defined as y is equal to 2x plus 4. The set of all lines with slope 2 will be related to what? Will be related to y is equal to 2x plus 4. Now how to represent the equation of a line? Y is equal to mx plus c, where m, the slope happens to be 2, therefore y is equal to 2x plus c is the equation, the general formula of the family of lines that are related to the line y is equal to 2x plus 4. Got the point? Any doubts, people? Fine. Now, next question. Show that the relation R that is defined on set A. Here, I'll tell you what is set A. Set A is the set of all points in a plane. Well, how to represent a point in a plane? Point P, point Q, point R, point S, point T, etc. etc. So this set contains many points that can be represented as P, Q, R, S, T, U, etc. Now the relation is defined as set of all points P comma Q. See, two points can be related P comma Q if distance of the point P from origin. Please tell me what is the distance of point P from origin. From A to B will be AB. From origin to P will be OP. Yeah, OP is same as, or it is equal to the distance of the point Q from origin. What is that? Q from origin will be OQ. Okay? The question is that you're supposed to show that this relation is an equivalence relation. So, remember, here you are supposed to prove the relation is reflexive, symmetric, and transitive. And hence you can say the relation is an equivalence relation. Okay? Fine. Gentlemen, tell me what is happening here. In order to check reflexivity, focus on the set. If set contains P, the relation must need to contain P comma P. If the relation contains Q, then if the set contains Q, then the relation must need to contain Q comma Q. Okay? So people tell me, here I am saying that P is an element of set A. Whether P comma P will be there in the relation or, that is the question. Whether P comma P is there in the relation or, yes. Why? People, P comma Q will be there, or P is related to Q if OP is equal to OQ. Now tell me, R comma S will be there in the relation if OR is equal to OS. Yes or no? Yes. Then P comma P, what is P comma P? OP is equal to OP. Whether OP is equal to OP? Yeah, obviously OP is always equal, right? Since I can say that OP is equal to OP, here P comma P belongs to R. So for every P belongs to set A, I can say that for every P belongs to set A, I can say that the reflexive pair, that is P comma P, will be always there in the relation, and hence the relation is always reflexive. Now tell me, what is the criteria for symmetricity? Tell me, guys. If I'm saying that P comma Q is an element of the relation R, then whether Q comma P will be there in the relation R? Yes. Why? People, P comma Q is there in the relation, which means that OP is equal to OQ. Now conversely, can I say OQ is equal to OP? Yeah. In that case, Q comma P will be also there in the relation. As why? OQ is equal to OP. Put all this condition. These people itself all this condition. So you can say that the relation is always symmetric. Now by the way, with this, whether this relation is transitive? Yes. Why? Why this relation is transitive? See, here P comma Q and Q comma R belongs to, let me call this a third point as Q comma S, as the R is the term that we use to represent the relation. See, if these two pairs, if these 2 points are there in the relation, what is the meaning of that? People tell me, what is the meaning of that? P comma Q is there in the relation, which means OP is equal to OQ. Okay. Now Q comma S is there in the relation, which means OQ is equal to OS. Okay. Now my question is that from this condition, can you tell me whether OP is equal to OS? Yes. OP equal to OQ, and that OQ is equal to what? OS. Therefore I can say that OP is equal to OS. In other words, P comma S will be always an element of relation now. Therefore, the relation will be transitive. Got the rule? The condition for reflexivity, symmetricity, and transitivity is being satisfied by this relation R that is defined on a set of all points in the XY plane. Clear? Any doubts, people? Now there exists one more simple thing. Find the set of all points that are related to the point P, which is not equal to 0. Is the circle passing through point P with origin as its center? Wow. Guys, listen. People, tell me, what are the points related to P? The points related to P are Q. If OP is equal to 1, if OP is equal to OQ. Whenever you found this length is equal to this length, then you can say that Q will be related to P. That is a basic logic. So question is that find the set of all points related to point P. People, the points related to point P is equal to what? Q itself, which satisfies OP is equal to what? OQ. So if I'm having something like this, people listen. I'm having something like this, OP. Okay, so my question is that tell me what are the points related to P. The points related to P are Q, so that I will be having the pair P comma Q. Why? Because OP is equal to OQ. So all the points Q which satisfies OP is equal to OQ are the points that are related to this line. Guys, tell me, OP is equal to OQ. Tell me what are those points that satisfies OP is equal to OQ. You can define a line like this. You can define another point Q such that this will be like this. You can define another Q such that this will be like this, like this, like this, like this. So the logic is very simple. You can say there exists a number of points Q which satisfies this condition. And the locus of all these points, the collection of all these points, joined to be what? A circle whose center is at origin and the radius is equal to OP. It is well mentioned in the question is that P is not equal to 0, 0. Why? P is not equal to 0, 0. People, if P happens to be 0, 0, what happened? People, if P is equal to 0, what happened? P is at the origin. If P is at the origin, then tell me what is the radius of the circle? 0. Radius becomes 0. If P is equal to 0, 0, radius is equal to 0, which means the circle does not exist. Or you see how to call this one? OP will be becoming O. P is equal to O. P, therefore O. It is not a line, it is a point origin, right? Therefore, the circle does not exist. That's why they are mentioning P is now equal to 0, 0. Clear, people? Fine. So, can I go for the next question? Alright. Now, let me give you a beautiful question that has been asked twice in the previous year. Show that the relation R defined by A, B related to C, D. Wow. Such that A plus D is equal to B plus C. The relation that is defined on what? A cross A. A cross A. Where A is equal to a set of 1, 2, 3, etc. up to 10. People, there are a number of things which I remember while dealing with this question. See, the relation is defined on what? If the relation is defined on, if R is defined on P, what is the meaning of that? The relation will be defined like P to P. P to P. Yes or no? This is very, very important. If the relation is defined on set Q, then this guy will be from Q to Q. If the relation is defined from E to E, the relation is defined from E, which means that the relation will be defined like E to E. Yes or no? Yes. But here, the issue with this statement is that the relation is defined on what? The relation is defined on, the relation is defined on, R is defined on A cross A. Well, what is the meaning of that? Here the first set is A cross A and the second set is also what? A cross A. Such a relation that can be defined among these two sets is the relation R. Okay? Now, people, what do you mean by A cross A? A cross A is a Cartesian product from A to A, where A is equal to set of 1 to 10. People, if this is A, this is also A, such that A contains 1, 2, 3, etc. up to 10. 1, 2, 3, etc. up to 10. My question is that, tell me what is the Cartesian product A cross A that can be defined like this. A cross A is equal to, how do you define the cross product of the Cartesian product? Here, every element in the set A will be related with or cross with every element in set A. So what will be the result? If you're crossing 1, 1 to 1, then we'll be having the pair 1, 1. Then 1, 2. The next one, 1, 3, 1, 4, etc. up to 1, 10. And similarly, you're supposed to cross with 2. 2, 1, 2, 2, 2, 3, etc. up to 2, 10. 2, 1, 2, 2, etc. up to 2, 10. Similarly, there will be what? 3, 1, 3, 1, 3, 2, etc. up to 3, 10. Now, 4, 1 to 4, 10. 5, 1 to 5, 10. And etc. up to, see, 1, 1 to 1, 10. 2 comma 1 to 2 comma 1, 3 comma 1 to 3 comma 1, 4 comma 1 to 4 comma 1. At the end, you can see the last element, that is 10 comma 1 to 10 comma 10. How many elements will be there in this Cartesian product? There will be 100 elements. So, here remember, these are the elements of what? This set. What are the elements? Ordered pair 1 comma 1, ordered pair 1 comma 2, ordered pair 1 comma 3, ordered pair 5 comma 6, etc., etc. So in that case, this set A cross A contains what? These pairs were like 1 comma 1, 1 comma 2, etc. up to 1 comma 10. Sorry. And 2 comma 1, etc. up to 2 comma 10, and finally the last element 10 comma 10. These are the sum of the few elements among the Cartesian product. Alright, now people, after understanding this, what is the relation, what is the set where the relation is defined, you have to define how they are crossing, how their relation will be satisfied. Let me show you. Wait. Here, after understanding the clear picture of the idea of the set, now tell me what is the relation. Here, one ordered pair A comma B will be related to another pair C comma D. One pair A comma B will be related to another pair C comma D as per the relation R, as per the relation R that is given by A plus D. See, A plus D is equal to B plus C. Whenever you see two pairs which satisfies this condition, then you can say that there exists the pair A comma D and B comma C. This will be a pair in the relation R. Gentlemen, you need to make this idea very clear. What is that? Usually a relation contains A comma B. If A is equal to something, A is equal to 3B, A is equal to B square plus 1, a relation that is connected between A and B. Here the issue is with that, here the two elements are not A and B. Here the two elements are not A and B. Instead, they are two pairs, one ordered pair with another ordered pair. Got it? Now, the relation that they need to satisfy is that A plus D is equal to B plus C. People, it was really difficult for me to understand the relation as per the condition they given in the question. So, let me make some rearrangements. How? See, I need AD. So, here A plus D is equal to B plus C. I think we can apply it over here, right? Yeah. A plus D is equal to B plus C. You can go for the direct question. No issue, no issue. Sum of this, what is that? Oh, wait. This is not A comma B. Sorry, it's my bad. A comma B will be related to C comma D. Okay, now fine. Now here, two pairs A comma B will be related to C comma D if A plus D is equal to B plus C. So people, how to make this better understanding here? Bring the B over here, therefore this will become A minus B. A minus B is equal to C minus D. People, I think this is a better way of understanding the relation. See, if you found A minus B, see, this guy minus this guy is same as C minus D, this guy minus this guy. Okay, then you can say that these two people will be related. That is the way how you usually interpret the relation. What is that? If the difference of this person and the difference of this person are the same, then yeah, the two pairs will be related. In that case, tell me some of the elements in the relation are, so that you can have a better understanding about the relation. Okay, fine. I am saying that 1 comma 1 is a one element. So tell me what are the elements related to 1 comma 1. Can I write 3 comma 3 here as a relation of Yes, why? People 1 comma 1 is there, which means that difference of 1 minus 1, what is that? 0. Difference of 3 minus 3, what is that? 0. So I can say that this pair, this element A is related to this element B. So that this will be one of the pair. Okay? Now it will be another pair. 3 comma 2. People tell me what is the difference of 3 and 2. 3 minus 2 will be 1. Tell me another pair whose difference equal to 1. Can I write 5 comma 4 here? Yes. What is the difference of 5 and 4? 1. 3 and 2, 1. Therefore, I can say that this will be one pair, A comma B. Okay? It will be another pair. 10 comma 7. What is the difference of 10 and 7? 3. So tell me another pair whose difference is equal to 3. 6 comma 3. Was it okay? Yes. So see that there are a number of elements, okay, which I'm not going to write, but remember this is how the pattern works here. Now after knowing the trend, you can go for checking what? Reflexivity, symmetricity and transitivity. Tell me reflexivity. Tell me an element of set A. Set A cross A. A cross A contains not 1. Instead, set contains 1 comma 1. People, if there is 1 comma 1 there in the relation, in the set A cross A, then whether 1 comma 1 and 1 comma 1 is there in the relation or not. Yes, why? Because difference of 1 and 1, 0. Difference of 1 and 1, 0. So every element will be related to itself. Yes or no? Yes. If you take an element 3 comma 7, this guy belongs to set A cross A. Then 3 comma 7 will be related to 3 comma 7. Yes or no? Yes. Why? Because this odd pair A comma B will be there in the relation as difference of 3 and 7 is same as difference of 3 and 7. You got the point? In such a way, if I take any pair, I can say that the reflexive pair will be satisfying the reflexivity condition. Therefore, I can say that for every A comma A belongs to the set A cross A, I can say that the reflexive pair, that is A comma A and A comma A, will be there in the relation R, belongs to relation R. And it's not necessary that this has to be A comma A. People make this as A comma B. For every A comma B belongs to A cross A, I can say that A comma B comma the same thing, that is A comma B will be there in the relation. Therefore, the relation is reflexive. That is how we are defining reflexivity. Alright? Fine. Now, people tell me whether this relation is symmetric or not. Symmetric or not. This relation is symmetric or not. Tell me a pair. A pair which satisfies this relation will be 3 comma 4 will be related to, what is the difference of 3 and 4? Minus 1. So tell me a pair whose difference is equal to minus 1. 5 comma 6. This will be a pair in the relation now. Yes or no? Yes. What difference of 3 comma 4? Minus 1. Difference of 5 and 6? Minus 1. Therefore, I can say that this will be a pair in the relation. Now, if A comma B, what I say? If A comma B is there in the relation R, whether B comma A, what is B comma A, people? Tell me what is B comma A. B comma A will be this guy, 5 comma 6 and 3 comma 4. Whether this person will be in the relation R? Yes, obviously. Why? 5 comma 6 difference is equal to minus 1. 3 comma 4 also the same thing. So I can say that for any pair, how do you define this generally? For any pair which satisfies, see, A comma B is related to C comma D. Therefore, A comma B and C comma D belongs to the relation R. I can say that the symmetric pair, that is C comma D and A comma B, will be also there in the relation R. Therefore, I can say that the relation will be what? Symmetric. You have to remember one simple thing. Here, A and B are not the points. The points are ordered pair. So whenever you see a point, instead of having point, you'll be having what? Pair. Because the relation is not defined on A. Instead, it's defined on A cross A. So every point will be converted into what? A ordered pair. Okay. If you have a better understanding, a better observation, you can make this one very clear. So I found that the relation is reflexive and transitive. Alright. Now tell me what is the final one. You found reflexive and symmetric. Tell me what is the final one, that is transitivity. Tell me what is the rule of transitivity. People, here you found that an element 1 comma 3 is related to some element. Tell me what is the difference of 1 and 3? Minus 2. So tell me a pair whose difference is minus 2. What is that? 2 comma 4. Yes or no? So I found that this guy is an element of relation R. Now you have to tell me another element which is starting from this 2 comma 4. 2 comma 4 comma 5 comma 7. Alright, these are the two pairs that are related to the relation R, such that I found this is A, this is B, and this is same thing, B, but the next one will be C. So if I found A comma B and B comma C in the relation R, you have to go for checking whether their transitive pair, that is A comma C is there in the relation or not. What is the transitive pair, people? The transitive pair is 1 comma 3 and 5 comma 7. People, whether this person will be there in the relation? Yes. Here the difference is minus 2. Here the difference is minus 2. So obviously I can say that this person will be there in the relation. So this enables us to understand that for any pair you take here, see, they will be following this strategy. What is the strategy? See, if you take one pair here, they will be having some difference. For example, minus 2. This pair will be also having minus 2. Now you have to start someone with same difference minus 2. Will be related to someone with same minus 2, difference of minus 2. So obviously this person will be also related. So you can conclude this point over here. What is that? The point is that here if A comma B and C comma D is there in the relation, and something starting from C comma D, that is C comma D and E comma F are there in the relation. In that case, I can say that A comma B will be related to what? E comma F. Got it? This guy will be there in the relation. For every A, B, C, D, E, F belongs to set A. So I can conclude that this relation is reflexive, symmetric and transitive. Gentlemen, remember there is a little confusing part element in this question, but if you have a better understanding, a simple understanding, what is that? What is that? Here R is not defined on A, but instead A cross A. Usually A contains elements like 1, 2, 3, 4. here, but here the relation is defined on A cross A, so that here instead of having elements like 1, 2, 3, 4, the elements inside this set will be 1 cross 1, sorry, 1 comma 1, ordered pairs. So for every A comma B you see, you will be seeing what? Ordered pairs here, 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 everywhere. Clear? Fine, excellent. Now let me give you one more question. Check whether the relations are defined by A comma B such that A is less than or equal to B cubed is a reflexive, symmetric or transitive. So checking reflexivity, checking symmetricity, transitivity. So people, you have to think about all the elements where the relation is defined. See, the relation R is defined on capital R. What do you mean by capital R? Real numbers. Not in natural numbers, not in integers, but the relation R is defined on a set of real numbers. Now the question is that two elements in the real numbers A comma B are related if and only if A is less than or equal to B cube. So we are having number of elements satisfying this. But you have to think about all the elements. If there exists at least one element, one pair, which doesn't satisfy the reflexivity or symmetricity or transitivity, you can say that the relation is not equivalence. People tell me how it works. For example, 1 less than or equal to 1 cube. Well, this condition is true. 1 either less than or equal to 1 cube. So 1 is equal to 1 cube, therefore this element will be there. Such a way that you have to think about all the possible ways. But here you have to learn some numericals. What are they? People, 1 by 2 comma 1 by 2. Whether this guy will be there in the relation or not. In order to happen A comma B, if A comma B is there, then A should be less than or equal to B cube. See? If A comma B is there, then A should be less than or equal to B cube. So, in order to happen 1 by 2 comma 1 by 2, then the first thing 1 by 2 less than 1 by 2 the whole cube will be there. Supposed to be there. Okay. So, what is 1 by 2 the whole cube? 1 by 8. So, 1 by 2 is either less than 1 by 8 or 1 by 2 is equal to 1 by 8. If both of the condition is wrong, which means that if 1 by 2 is an element of set A. Here set A is equal to real numbers. But let me call this set A as real numbers because we don't confuse with the relation R. Here 1 by 2 is an element of set A, which is real numbers. But its reflexive pair, that is 1 by 2 comma 1 by 2, is not there in the relation R. Therefore, I can say that the relation is not symmetric. Therefore, the relation is not symmetric. Sorry, reflexive. The relation is not reflexive. Alright? Let me tell you what is the condition for symmetricity. If A comma B is there, you are supposed to check whether B comma A is there or not. So, I am thinking about a pair which satisfies or doesn't satisfy this condition. Let me take a common pair like 1 comma 4. People, whether 1 comma 4 is there in the relation or? In order to happen that 1 is less than or equal to 4 cube, yeah, obviously this guy will be there. Now conversely, whether 4 comma 1 will be there in the relation R, this guy will be there in the relation R. In order to happen that 4 should be less than or equal to 1 cube. This condition is true? No, this cannot be happening here. Therefore 4 comma 1 does not belong to R. So here you can realize that 1 comma 4 belongs to R, but its symmetric pair, that is 4 comma 1, does not belongs to R. Therefore the relation is not symmetric. So we found not reflexive, not symmetric. Now the final one is transitive. It will tell me what is the rule of transitivity. The rule of transitivity is that if A comma B and B comma C is there, you have to go for checking A comma C is there or not. It was found that 9 comma 3 and 3 comma 2 will be there in the relation. So my question is that whether 9 comma 2 is there in the relation or not. Whether 9 comma 3 is there in the relation? Yes. Why? 9 is less than or equal to 3 cube, which is 27. 3 comma 2 is there? Yes. 3 is less than or equal to 2 cube, that is 8. This condition is true. This condition is true. Alright, now this condition will be true. They are transitive pair. 9 is less than or equal to cube, that is 8. 9 is less than 8, not true. 9 is equal to 8, not true. Therefore, this guy does not belongs to R, as 9 is not less than or equal to 8, which enable us to understand that the relation is not transitive. People, the method of justifying the condition of reflexivity, symmetricity, transitivity is something very, very, very important. If you need to prove that they are not reflexive, not symmetric, not transitive, you have to highlight one single example of why not being transitive, why not being symmetric, why not being reflexive. But on the other hand, if you're supposed to prove that this is reflexive, this is symmetric, this is transitive, you have to highlight the definition of what? Symmetricity, reflexivity, and transitivity with some of the conditions that is given as per the relation. Alright? Fine. Gentlemen, I've done almost 4 questions from the area of reflexivity, symmetricity, transitivity. I hope that you guys got a clear idea regarding equivalence relation. Now, let me talk something about functions. Tell me what are the things you are learning from functions. After learning what exactly is a function from the 11th, the 12th curriculum is highlighting what are the different types of function, which includes injectivity, injective function, and surjectivity, surjective function. Or in other words, you can call them as 1, 1, or 2. And if you found that if a function is both injective and surjective, both ejective, you can call such a function as bijective function. Okay. Now, here in this question, tell me what they are saying. Show that the secant function defined by f of x is equal to 1 if x is greater than 0, f of x equal to minus 1 if x is less than 0 is neither 1, 1 nor 1, 2. Guys, listen here. F of x equal to 1 if x is greater than 0. People, this is x greater than 0. For all x greater than 0, it was found that the y value, y is equal to f of x is equal to what? Y is equal to 1. Represents a horizontal line passing through the point origin. So you will be getting something of this kind. That happens only for this point. Why this is not happening here? Because if x is less than 0, it was found that the y value is equal to minus 1. Y is equal to minus 1. So for all negative value of x, you can see something like this. Y is equal to minus 1. See, here both these points should be excluded. Why? Because at the point x equal to 0, it was found that the y value was found to be equal to 0. So gentlemen, the secant function is defined in such a way that we are having 3 set of values, either minus 1 for all x less than 0, and y is equal to 1 for all x greater than 0, and equal to 0 for all x is equal to 0. Now, the question is that whether the function is 1, 1 or 2 or no. So checking number 1, checking the condition of 1, 1. 1, 1 also known as injectivity. People tell me what is the rule of 1, 1 or injectivity? It states that every distinct element of set X have distinct images on set Y. Every people have different elements on what? Second set B. Which means no two people should have same image. No two people should have same image. Everyone should have unique or different images. If we found two elements of set X is having same ending point, same terminal point in the second set, it means that they are not 1, 1. So here, tell me what is the y value when x is equal to 2. When x is equal to 2, see, when x is equal to 2, the y value is equal to 1. Y is always constant. When x is equal to 3, y is always equal to 1. Again, it is constant function. When x is equal to 4, y is equal to 1. So this is a way that you can say that for every positive numbers like 1, 2, 3, 4, 5, 6, you can see that the y value merges to a common point. What is that? 1. This is the first example to highlight that the relation, the function is not 1, 1. Got the point? So highlight by using this example is enough. Here you can solve, you can realize that the function is not 1, 1. Now how could you prove the function is not onto? What is the rule for onto? The condition for onto surjectivity is that you have to focus on second set. If every element in the second set have got received arrow mark from the first set, in other way, I can say that every element in the second set are the images of some of the elements of set A. You can say that the function is surjective or onto. So remember here the relation R is defined on real numbers. People, tell me what is the meaning of that. Checking surjectivity. People listen. Checking surjectivity, that is onto condition. Here, the relation was defined from R to R, which means the second set contains the entire real numbers. But it was found that here, if you put 0, the y value is equal to 0. But if you put 1, 2, 3, 4, for all positive numbers, this value merges to be 1. Now, if you put any negative value, -1, -2, -3, this value was found to be equal to -1. So my question is that whether there will be a y value other than these 3? No. Only for any value put x in here, the only possible set of y values will be 0, 1, -1. That is the speciality of what? Signum function. But remember, here the second set is real numbers, which contains number of elements other than these 3. So for those elements, they are not having what? They are not receiving an arrow mark from the first set, or they are not having what? Pre-images. Okay, so here I can say that if y is equal to 3, y is equal to 4, the elements like y is equal to 3, y equal to 4 does not have what? Pre-images on set of real numbers. So I can say that here the function is not onto. Clear? So the function is neither 1, 1 nor onto. People, can I tell you, other than this algebraic definition, can I tell you the graphical meaning of this thing? If you get the graph, you can easily interpret how these things works. Remember, for proving surjectivity, you have to remember this simple rule. If every element in the second set is receiving arrow mark, you can say that range is always equal to codomain. Why? Codomain is always the second set. Now what is the range? Range is that elements in the second set where the arrow mark are receiving. Now for calling a function as surjective, every element in the second set should need to get arrow mark. Should need to receive arrow mark. Or they are the images of some of the elements in the first set. So in that case, the range will become what? Codomain. Actually, this is a rule for what? Surjectivity. Now, by looking at this graph, tell me what is a codomain. Codomain is the entire real numbers, which means this entire thing will be the entire thing, y-axis will be the set of real numbers, which is known as the codomain. Okay, now tell me what is a range. Range is a set of y values. How can you bring the set of y values by looking at the graph? You do one thing, you just put a clamp like this. You just merge all this thing over here. If you put something like this, all y values will be 1. If you put like this, you can see all the y values will be here, y values will be here. So it was observed that the entire thing is the codomain. But the range is equal to either this one, either this one, either this one. So you can say that by looking at this graph, the codomain and the range are not the same. Okay. the range is equal to set of 1, 0, minus 1. What is Codomain? Real numbers. So it was found they are not equal, which means that the function is not onto. This is a graphical interpretation of what? Checking surjectivity. Now, how could you prove injectivity or one function based on the graph you see? You have to draw any parallel lines. You have to draw any parallel lines. You have to draw any parallel lines. If you found if the curve intersects is more than one point, it means that the function is not 1, 1. Let me explain for you one detail with a beautiful example. Guys, listen. The function are defined as f of x equal to x raised to 4. People, how to picture this graph? X raised to 4. X square will be something like this, right? The parabolic curve. This is x square. Then tell me what is x raised to 4. X raised to 4 will be much more steeper like this. Okay? X raised to 4. X raised to 4 will be this curve. So, by looking at this curve, how could you prove that this function is 1, 1 or not 1, 1? Check by injectivity. You have to do one thing. You have to draw any parallel line, parallel to x-axis. You can draw over here, here, anywhere. If any of these parallel lines intersect at more than one point, it can be 2 point, 3 point, 4 point, but if it intersects at more than one point, remember that function is not onto. See, at this point they are not all intersecting. But at this point, at this line, you can see that they are intersecting more than one point. See here, this, what is the peculiarity of this curve? This curve is intersecting at here and here. It means that for example, x is equal to 1 and for x is equal to minus 1, the y value is equal to what? The y value is equal to 1, which means that for both two x values, for x value 1 and minus 1, we are having the same y value of 1, which is not possible. Okay, so remember the algorithm. The first one is draw any line parallel to x-axis. Number 2, if it intersects more than one point, it means that they are not on 2. So they are not 1, 1. Okay, now this is a graphical method of proving. Now for the board examination, how could you prove? We just mentioned this thing. It was found that for both 1 and minus 1, they do have the same image. They are not having distinct image, therefore not onto. Highlight by using any of the example which shows that they are not onto, not 1, 1. Okay, now tell me whether this guy is onto or not. What is the graphical method interpretation you have to make for proving they are onto or not? You do one thing, you do a clap like this. Okay, so if you're doing something like that, see, tell me what are the y values you obtain here. If you're merging all the points, you can see that these points will be here, here. The entire positive y values are the set of values which can be obtained as range. But codomain will be the entire real numbers, which was found to be that they are not equal. You will never get negative y values here, negative range here. So which means that range and codomain are not equal here, which means the function is not onto. This is a graphical method of explaining whether it is 1, 1 or onto. Now, by the way, how could you prove for the board examination? It was found that range is equal to this one, only the positive y value, which means there are negative y values which does not have pre-images on x. So how could you write this? For all negative real numbers, we are not having images on first set. Clear? Let me do one more example. Please tell me what is happening here. Y is equal to 3x, that is defined on R to R. So y is equal to 3x. Please tell me the graphical interpretation, and hence we can go for the algebraic way. Y is equal to 3x will be representing the family of curves which is passing through origin. Y is equal to mx. As m increases, theta increases, tan theta changes, therefore m changes. Okay, but they represents a curve that is passing through origin. Okay, this is y is equal to 3x. Y is equal to 3x. Now people, once you go a curve like this, by looking at this graph, tell me whether it is 1, 1, 1, 2. I need both methods because graphical interpretation are highly useful for dealing with 1 mark MCQ. People, once you got a function, after plotting the points, you'll be getting a curve. Once you obtain the curve, tell me how could you prove that this function is 1, 1 or on 2? Tell me. For checking 1, 1, you have to draw a parallel line. See, it was found that any parallel you draw over this thing, intersecting at only one point. They will never intersect at more than one point. Which means that the function is 1, 1. Now, how could you prove the onto condition based on the graph? Just put this thing, clapping method. If you clap, you can see that all the y values merges. See, this value merges here, this merges here, this here, this here, this here, this here, this here, this here. And the real numbers will be obtained. Yes or no? Yes. And the real numbers will be the range, and the codomain is always real numbers. It is given in the question. So I can say that your range is equal to codomain. Your range is equal to codomain. Therefore, the function is onto. This is a graphical way of analyzing the function is 1, 1 or onto. Clear? But remember, this can be only applied for 1 mark MCQ. Okay, you can never answer this kind of method of answering for the 2 mark, 3 mark distributive type of where we need algebraic explanation. Okay, so you have to highlight by using the example, especially if it are supposed to prove 1, 1. If you are supposed to prove 1, 1, you have to write the definition, write the condition for onto. If you are supposed to prove it is. But if you are saying that they are not 1, 1 or they are not onto, highlight with any one simple example. That's enough. Now people, let me wind up this section with one more question. Listen. A function that is defined on natural numbers, which means n to n. Natural numbers contains 1, 2, 3, 4, 5, 6, etc. up to infinity. This also contains the same thing. Now, if this is x, this happens to be y, such that y is equal to a function of x. But it was given that, this is equal to n. N belongs to set of natural numbers. Then you'll be having what? You'll be having y is equal to f of n. Okay, that is defined as f of n is equal to n plus 1 by 2 if the value of n is odd. See, this is where n you can see n. If the value of n is equal to 1, which means odd number, then the y value is equal to n plus 1 by 2, which means 1 plus 1 by 2, which means the value is equal to 2 by 2, that is 1. So we'll be having the pair 1, 1. Now, if you take n is equal to 2, which is an even number, then the y value happens to be what? N by 2. So what is 2 by 2? 1, which means that we'll be having 2, 1. And similarly, if 3 will be having 2, 4 will be also having 2. 5 will be having 3, 6 will be also having 3. Okay, so gentlemen, my question is very simple. Tell me whether this function is injective, that is 1, 1 or not. The function is not 1, 1 because both 1 and 2 is having the same image of what? Same image of 1. Therefore, the function is not 1, 1. Now, whether the function is onto here, surjective over here, tell me. Whenever you are supposed to check surjectivity, you have to focus on the second set. If all elements in the second set have received the arrow mark from the first set, you can say the function is onto. It was found that every element in the second set is receiving two arrow marks, right? One is receiving from 1 as well as 2. 2 is receiving from 3 as well as 4. 3 is received from 5 and 6. As you pay that if you take any of this one pair, they can receive arrow from 2 elements, which enable us to understand that the function is onto. So if you need to prove the function is onto, what you have to do? Write the definition of onto. What is that? Here, every element in the second set are having pre-images on first set. Clear? Gentlemen, this is the way you are supposed to learn the injectivity and symmetricity and transitivity. Alright? Well, that's enough. Thank you. Thank you for your valuable cooperation. So, see you guys.
Hi, hello everyone. Welcome back to Excel Education Center. Here today we are going to discussing the chapter differential equation. The relations functions are already done. So now we are going to do the chapter relations and functions. Hope you are all are doing good. And here the first question. Actually this chapter is very easy because you have already learned the differentiability and integration. So here you only need to learn three methods, that is variable separable form, linear differential equations, and homogeneous differential equations. Okay, there is no very hard method to find the solution of a differential equation. What we mean by a differential equation? A differential equation is a equation that contains the derivatives. That's a simple or informal meaning of differential equations. Okay, anyway, we can go to the first question, that is the sum of the order and the degree of the differential equation. They have given you a differential equation. You can see here d square y by dx square plus dy by dx the all cube is equal to sine y. It is a differential equation because it contains the derivatives, that is d square y by dx square and dy by dx. Let me ask you one question. Which derivative have the highest order, having the highest order, or how many times if you differentiate a y, if you differentiate a function y, one time you will get dy by dx, you will get dy by dx, and this is first order. And if you differentiate it again, you will get d square y by dx square, that is second order. If you differentiate it again, you will get d cube y by dx cube, that is third order. So the order means how many times you differentiated the function, or how many times you have differentiated the entire equation that have been used to create this particular differential equation. So here you can see the highest order is d square y by dx square. Therefore the order of this particular differential equation is 2. Order is 2. What about the degree? Degree means the power of the highest order. The degree of a differential equation is power of the highest order derivative. Here the highest order derivative is d square y by dx square, and the power of that is 1. Therefore degree will be equal to 1. Listen guys, for all differential equation there is no degree. Some of them don't have degree, or the degree is not defined for some of the differential equations. Why? Only the degree is defined for polynomial differential equation. Only for polynomial differential equation. Ready? Listen. So it is a polynomial differential equation. I will give you another question to understand what is polynomial differential equation. Here the order is 2 and degree is 1, and they ask for sum of the order and the degree. Sum of order and degree, that is 2 plus 1, that is 3. The answer is 3, option C. Did you get the answer? All of you? Give me some high or something. Okay, did you get it? Everything is fine? Okay, clear? Can I move to the next question? Ready? So the point is the degree is defined only for a polynomial, that is a differential equation, that is a polynomial differential equation. So we can move to the next question. Listen guys. Degree of the differential equation sin x plus cos of dy by dx is equal to y square. What does that mean? Look at here. It is a function. It is a trigonometric function, and the derivative is inside the trigonometric function. The derivative is inside the trigonometric function. Then it is not a polynomial function. Then it is not a polynomial function. Polynomial differential equation. If a derivative is inside log, like this, log dy by dx equal to 1 equal to something sin x or something, then in this case, this is not a polynomial differential equation. What we mean by a polynomial, what do we mean by a polynomial? A algebraic expression that only contains positive integers as the power. Positive integers as the power. Positive integers, only the positive integers. So, and it will not contain any other trigonometric functions or something like that. Here you can see, here we can see there is a cos, and the parameter inside the cos is a derivative. That is not allowed. If it is like this, like sin x plus cos x into dy by dx is equal to y square, it is fine because the parameters are x, not derivatives. Here the derivative is standing separately from these functions, okay, these trigonometric functions. Okay, then it is a polynomial differential equation, but it is not a polynomial differential equation because it is the derivative is inside a trigonometric function. It can be a logarithmic function, exponential function, whatever it is. So for that case, this is not a polynomial differential equation, therefore the degree is not defined and the answer is C, that is not defined. Okay, I think you get it, guys. Okay, can I move to the next one? Listen, what is the product of the order and degree of the differential equation? It's an easy one. Look at it. Here the derivatives are standing separately from other functions like trigonometric functions, logarithmic function, exponential function, inverse trigonometric functions. So now we can say the order of the differential equation is 2 because the highest order is 2. Order is 2 and degree is what? And degree is the power of the highest order, that is 1. Then what you will get? They ask for the product, right? They ask for the product of these two. 2 into 1 become 2. The option is B. Okay, I think you get it. Okay, can I move to the next one? Can I move to the next one? Okay, the next question is, find the solution of the differential equation dx by x plus dy by y is equal to 0. Listen guys, there is 3 ways to find, there is 3 methods to find the solution of a differential equation. That are, the first one is variable separable, second one linear differential equation, and third one homogeneous differential equation. These are the types of differential equations that can be, the solution can be found in different ways. So here you can see it is a variable separable question. I will show you how to find the answer. If you can separate the variables, like here 2 variables is there, that is x and y. If you can separate these variables, you can integrate it separately and you will get the answer. The solution of the differential equation means you have to find the function, that means the y. Ready? If dy by dx is there, you want to find y. The y is the function, and then that is the solution of a differential equation. Here you can see, listen guys, here you can see dx by x is equal to minus dy by y. Okay, here I take this dy by dx to the right side and you will get what? Negative dy by dx. And I'm going to integrate the both sides because integration is the inverse process of the differentiation, and we can cancel off the derivatives by integrating the both sides. So what you will get? Integral 1 by x dx is log mod x, which is equal to negative log mod y plus c. So I can write this c as log c also because it is a constant. Log c also a constant, so I can represent the c as log c to convey you how what. Otherwise we can do like this also. I always go like that. Otherwise you can do like this. I'm going to show you. Log mod x plus log mod y is equal to c. What is log x plus log y? That is log x into y. Log x into y is equal to c. Then you can put exponential function in both sides. You can apply exponential in both sides. What you will get? E raised to log xy is equal to e raised to c. Here you can see e and log will be cancelled, so you will get x into y, and e raised to c is another constant, therefore you will get c. So xy is equal to c. Here you can see the option is C. Xy is equal to C is the answer, and the option is C. I think you get it, guys. Give me some messages. Yes, okay, Santosh, you get it right. Okay, so shall we move to the next one? The next one, the general solution of the differential equation x dy minus 1 plus x square dx is equal to dx. You can see there is 2 dx here. So it's an easy question. It's also variable separable form. X into dy is equal to, there is dx at the right side. I'm going to take this one negative 1 plus x square dx to that side. You will get what? Positive 1 plus x square dx. So that x dy will be equal to, you can take this dx outside, then what will be here? 1 plus x square. Listen, 1 plus x square. Then you only need to take this x to that side. Then here dy is only here. Then what you will get? 1 plus 1, 2 plus x square divided by x dx. So now you can see that dy will be equal to 2 by x plus x square by x, that is x dx. You can see I can integrate the both sides. If you separated the variables, you can integrate the both sides to get the function y. So what is integral dy? What is integral dy? Integral dy is y. And what is integral 1 by x? You can take the 2 outside and there is only 1 by x left. So integral 1 by x is equal to log mod x. And finally plus integral x. Integral x is what? X square by 2 plus c. So the answer is y is equal to 2 times log x plus x square by 2 plus c. The option D is your answer. I think you get it. Give me some messages. Give me some messages. Okay, we can go to the next one. That is the general solution of the differential equation e raised to x tan y dx plus 1 minus e raised to x c square y dy is equal to, this is also a variable separable form. These questions are all past questions. And listen here. E raised to x tan y dx, I'll put that here, and I'm going to take this term to that side. Then what you will get? Negative 1 minus e raised to x sec square y dy. Then what happens? Here you can see this side you can find sec square y dy is there. Then I'm going to take this tan y to that side. Then what you will get? Divided by tan y. Ready? Then this negative go inside. What happens? This e raised to x become positive and that 1 become negative. That is e raised to x minus 1. I'm taking that to this side. It will become the denominator of the left side. E raised to x minus 1. And here the left side e raised to x is already there and dx. Now you can see I separated the variables in the left side of right side of that equation. Did you get it? Then I'm going to integrate both sides. Listen guys, integral of, listen. Integral of f dash of x by f of x dx is what? That is log mod f of x plus c. If there is a function in the denominator and the derivative of that function lies at the numerator, then the integral of that particular expression will be like log mod f of x. I think you get it guys. Then listen here. What is the derivative of tan y with respect to y? That is c square y. So it is f of y and it is f dash of y. Then the answer will be log mod f of y. That is log mod tan y plus c. And also here you can see what is the derivative of e raised to x. Derivative of e raised to x is e raised to x and derivative of 1 is 0. So finally the derivative of the denominator is at the numerator. Therefore the answer will be like what? Log mod e raised to x minus 1. Okay, and how will you end this one? You can put this as log c, then you can write a log a plus log b, that is log ab, that is c into tan y, and here log of e raised to x minus 1, and you can take exponent in both sides and you can cancel the log, and what is the things here? It is e raised to x minus 1 is equal to c tan y. Ready? Then finally you can take that c in this side, e raised to x minus 1 by c. You don't want to put c as in the denominator because 1 by c also a constant, so you can write c is equal to tan y. Ready? Then you can take the tan inside this side, tan inverse of c e raised to x minus 1 is equal to y. For every term you don't need to find the y. It is fine to write till here because we only need to find the function or the equation that is included in the function. Okay, so you don't want to find the y all the time. It is okay with till here. Ready? I think you get it right. Okay, all good. Can I go to the next one? The next question, listen. So that's all your variable separable type of questions. If you can separate the variables, you just integrate both sides, you will get the answer. Only the integration matters there. Here, this is a homogeneous differential equation. I'll show you how to solve this. Find the general solution of the differential equation xy minus x square into dy is equal to y square dx. First of all, I'm unable to separate the variables for this particular differential equation. That's why I choose it must be a homogeneous differential equation. Otherwise, it may be a linear differential equation, but the format of the linear differential equation is a little bit different from this type. So I'm going to write dy by dx from it. That is, dy by dx will be equal to what? Y square by xy minus x square. So I can write this equation like this, and I am unable to separate the variables also. So what we will do? I need every variables or every term in this particular equation in the y by x format. If I need, there is only y square at the numerator, but it should be y by x the whole square. All the variables, all the terms should be in the form of y by x. So what we will do? Listen guys. There is only one way to create the y by x format. The numerator is y square, the denominator is xy minus x square. The only way to make it y by x format is to divide it with x square. The numerator and denominator is divided by x square. Then what happens, guys? Then it becomes y by x the whole square, and this become what? The x and x will be cancelled. So I can write it like this: yx by x square minus x square by x square. Right? Then what happens? Dy by dx will be equal to y by x the whole square. And I cancel this x and this x square term. You will get y by x there. And finally, this x square cancels off, you will get 1. Now you can see every term of this differential equation is transformed into the form of y by x. Then I'm going to put this y by x as v. Then y is equal to what? Vx. I'm going to differentiate this thing. Actually, I'm going to substitute y by x as v. The substitution is going to done here. So dy by dx is equal to, I'm going to apply the product rule here. First function into derivative of x, that is 1. So into 1 plus second function x into derivative of v, that is dv by dx. So this is dy by dx. This is our equation 2 and this is our equation 1. I'm going to mix these two equations. I'm going to replace this dy by dx with this dy by dx, that is v plus x dv by dx. I'm going to replace this dy by dx with what? The second equation, that is dy by dx is equal to, I can replace dy by dx with what? V plus x dv by dx. Then what you will get? V plus x dv by dx will be equal to, dy by dx is equal to this. The y by x can be replaced to v square by v minus 1. Look here. Now, after doing this y by x thing, after doing this thing, our differential equation changed to variable separable format. At the first time, we are not able to convert this into variable separable form. But now we can change it into variable separable form. I'm going to separate the variables here. X dv by dx is equal to v square by v minus 1 minus v. Taking this v that side because I need to separate the variables. I'm also need to separate the x from it also. Listen here guys, listen. Wait a minute. Let me take this into that side. Okay. So here you can see x into dv by dx is equal to v square by v minus 1 minus v. So I'm going to take x into dv by dx is equal to v square minus v into, I'm going to take the LCM, v minus 1 all divided by v minus 1. So now you can see x into dv by dx is equal to v square minus v square plus v by v minus 1. Here you can see I can cancel these two terms here. Then what else is there? X into dv by dx is equal to v by v minus 1. Now listen guys, the dv is here. I want to take these terms to here. So this denominator comes to the numerator of the left side by the numerator comes to the denominator of the left side, which is equal to 1 by x dx. This x goes to the right side and become 1 by x, and this denominator, the dx in at the denominator goes to the right side and become dx. Then I'm going to integrate the both sides. Listen guys, this is going to end because integral v by v is 1 minus 1 by v dv is equal to integral 1 by x dx. And finally, what is the integral of 1 with respect to v? That is v. What is integral of 1 by v? That is log mod v, which is equal to log mod x. I'm going to put the c here for all that thing. Here you can see v is equal to, here you can see v plus c is equal to log mod x, and this negative log v goes to the right side, become log positive log v. Then what happens? V plus c is equal to log x into v, and I'm going to replace that v with what? V is what? Y by x. Then you will get y by x plus c is equal to log x into y by x. Then this x and x will be cancelled off, and the final answer will be y by x plus c is equal to log mod y. That's enough. You can put the c in this side also. Okay, that's all it. Because what is the meaning of homogeneous differential equation? If a differential equation can be written in this format, y by x format, then it is a homogeneous differential equation. And we put v as y by x or y by x as v. Then what happens when you combine these two equations? You will get a variable separable format. Then here onwards, what we are doing, the same thing we have done in variable separable. Okay, that's all this question. All good guys? All good? Ready? So we can go to the next question. Listen carefully. Solve the differential equation. So you can see there is y by x and you are not able to separate the variables. Then there is only one way. Homogeneous differential equation is that way. So how will you do this? Listen carefully. There is dy by dx. I need dy by dx. So I'm going to write x into dy by dx. I'm going to take this term to that side. Negative of x e raised to y by x minus y. So if I open this bracket with this negative, what happens? X into dy by dx become, this negative become positive y, this positive term become negative x into e raised to y by x. So but here is a problem. No, there is no problem because there is an x. So I can take that x into the right side. That x become the denominator of the right side, all divided by x. So finally dy by dx is equal to y by x minus x by x become cancels off, and y by x is equal to e raised to y by x. Then what's the next step? We want to put y by x is equal to v. Then what happens? Dy by dx is equal to v plus x into dv by dx. You don't want to do that all time because we have already done that step here. If v is equal to y by x, dy by dx will be like v plus x into dv by dx. We don't want to do it all the time. So listen, this is our equation 2 and this is our equation 1. Then we are going to put y by x in this equation, also changing the dy by dx with the equation 2. So v plus x into dv by dx is equal to what? Is equal to what? Y by x. Y by x is v minus e raised to v. You can see we can cancel these two v's from there. Then listen, this dx goes to that side and this x comes to here, become 1 by x. There is a negative sign, and this e raised to x at the numerator will come to the denominator, that is 1 by e raised to e dv, and finally I'm going to integrate both sides. What happens? Integral e raised to minus v dv is equal to minus integral 1 by x dx. So what is integral of e raised to x? That is e raised to x. Then what is integral of e raised to minus v? That is also e raised to minus v. But it is not x, it is minus v. It is not v, it is minus v. So we need to divide it with the minus 1. That's all. Which is equal to minus log mod x plus e. So the answer, I'm going to multiply the entire equation with the negative with this so that I can cancel this negative and that negative. Then what is the final answer? E raised to minus v is equal to log mod x. This positive become negative and negative c is also another constant, that is plus c. Then finally I can put e raised to, I can interchange the y with the v with y by x, that is e raised to y by x, negative y by x is equal to log mod x plus c. Also you can write it like 1 by e raised to y by x is equal to log mod x plus c. That's all. You can take that e raised to x if you want to that side or something. That's all the question. I hope you get this answer. Okay, can I go to the next one? Okay, the next one is solve the differential equation given by, and there is a differential equation. You can see these two terms contains dx. So I'm going to take that both into that side. Then what you will get? This become x dy is equal to y dx plus root of x square plus y square dx. And I'm going to take this dx outside. Then you will get what? Y plus root of x square plus y square x dy. Then I'm going to make the dy by dx here. So dy by dx is equal to y plus root of x square plus y square all divided by x. So that is dy by dx is equal to y by x plus root of, if I take that x into the square root, what happens? That happens x square plus y square all divided by x square. then only this become, when you apply the root to the x square, it become x, right? Then what happens? Dy by dx is equal to y by x plus root of x square, and x square will be cancels of 1, and there will be y by x the whole square. Now it is in the form of y by x format. Okay, did you get it? Give me some messages. Did you get it? All good? Okay, then we can go to the substitution part, that is v is equal to y by x, that is then dy by dx is equal to what? And dy by dx is equal to what? V plus x into dv by dx. So then this is our equation 2 and this is our equation 1, and finally what you will get? V plus x dv by dx, and replacing this dy by dx with this dy by dx and changing this y by x into y, v plus root of 1 plus v square. Ready? Then I can cancel these two v. Then what you will get? X into dv by dx is equal to root of 1 plus v square, and finally 1 by root of 1 plus v square dv is equal to 1 by x dx. I'm taking this dx and x to that side and integrating the both side. Ready? I'm going to integrate the part. I'm going to erase this part. If you want, you can pause this video and you can simply note down all the other things. Listen. What is the integral of? I'm going to give you one equation from the chapter integrals. That is, what is integral 1 by root of x square plus a square dx? That is log mod x plus root x square plus a square plus c. So here, this side of this equation is like integral 1 by x square plus a square. Here x is v and a is 1. So we can write the answer is like this: log mod v plus root of v square plus 1. That is your LHS, and RHS become integral of 1 by x, that is log mod x plus c. Here I can put the v as y by x plus root of y by x the whole square plus 1, and this log x to goes to that side, log of negative log mod x plus x is equal to c. And finally this is log a minus log b. You can write log a by b, right? That is y by x the whole square plus 1 all divided by x is equal to c, and the final answer is log of y by x square plus root of y by y square by x raised to 4 plus 1 by x is equal to c. And finally you can apply the exponent in both sides and you can write y by x square. This is your answer, y by x square plus root of y square by x raised to 4 plus 1 by x is equal to c. You can stop here or here till here, it's enough. Okay, can I move to the next one? All good? Ready? Okay, the next question is from, I think it is from the part of linear differential equations, because they are asking for the integrating factor. The integrating factor comes at the topic linear differential equation. What is a linear differential equation? If a function is like this, dy by dx plus py is equal to q. Here p and q are functions in y or constant. If a differential equation is like in this format, then we say that differential equation, linear differential equation. There is another type also. There is two type of linear differential equation. This one is px is equal to q. Here p and q are functions in, sorry, here the functions in x, actually here it is functions in y or constant. I think you get it. So I'm going to give you an example with this question, like here dx by dy 1 minus y square into dx by dy plus yx is equal to ay is the differential equation, and dx by dy plus y by 1 minus y square into x is equal to ay by 1 minus y square. Now listen here guys, this is I just divided all the equation with the 1 minus y square to make dy by dx alone, or the coefficient of the dy by dx 1. I want to make the coefficient of dx by dy as 1, because in linear differential equation the coefficient of dx by dy is always 1. So in that case you can see here it is 1 into dx by dy like this, and here a term multiplied with x, then it is our p, a function in what, a function in y. It may be a constants like 3 or 4, that is also applicable, and this is our q. Ready? If you get a differential equation like this, like linear differential equation, there is a thing that is integrating factor, that is e raised to integral p dx for this one, sorry, p dy for this one, and for this differential equation integrating factor is equal to e raised to integral p dy. Ready? p dx, because this function p and q is in the x format, so we can write e raised to integral p dx. Here it is e raised to integral p dy. Okay, and finally the solution of the first type of differential equation is like y into integrating factor is equal to integral of q into integrating factor dx. This will be our solution, equation of the solution of a linear differential equation. For this one it will be like x into integrating factor is equal to integral q into integrating factor dy. So these are the equation to find the solution of linear differential equations. So here they asked for the integrating factor only. So what is the integrating factor? I'm going to rub this part. What is integrating factor? Integrating factor is e raised to integral, it is p dx here, sorry, p dy here, because here the p is in the in terms of y. So listen, e raised to integral, I am going to put that p here, that is y by 1 minus y square dx. You can see what is the different derivative of the denominator, that is 0 minus 2x, sorry, 0 minus 2y, but there is only y there. If there is minus 2y, what happens? The derivative of the denominator is at the numerator, then we can integrate it more easily. So I put a minus 2 there and I compensate that minus 2 with minus 1 by 2 here. Then what happens? The derivative of this denominator is at there. So that you will get e raised to minus f log mod the denominator. Okay, we have already discussed that kind of thing. Then e raised to log mod 1 minus y square to the power minus 1 by 2 will be there. How that will happen? Log x raised to n is equal to n log x. So you can take the coefficient of log to the power of the variable inside the log function. So here the exponent function and log will be cancelled off, and you will get 1 minus y square to the power negative 1 by 2, and finally if there is negative 1 by power, you can write 1 by root of 1 minus y square, the power of 1 by 2, is root 1 minus x square. This is your sorry, this is your integrating factor. That's all. Okay, can I move to the next question? Here is our last question. Find the particular solution. Now you know how to find a solution of a variable separable format, in variable separable format, also in homogeneous, also in what, linear differential equation. Now we are going to find the particular solution. If they ask for a particular solution, in that particular solution there will not be any C. So listen carefully, listen carefully. Here, what format is this? Look at here, look at here, look at here. These two are our P and Q. So dy by dx plus py is equal to q. So this is a linear differential equation. So first we need to find e raised to integral p dx, because we need to find the integrating factor to get the solution. And what is the equation of the solution? The equation of the solution is y into if integrating factor is equal to integral q into integrating factor dx plus e. That's your answer. So here you can see e raised to integral p dx, e raised to integral, what is p? Here p is sec square x, here p is sec square x. Then e raised to integral sec square x is what? Tan x. So you got the integrating factor, that is e raised to tan x. And you can see then the solution is y into integrating factor, y into e raised to tan x, which is equal to integral, what is q? Q is tan x into sec square x into integrating factor, that is e raised to tan x dx plus c. This is our answer. Here, look at it here. Here we need to do some substitution. So I'm going to write this part as 1. So I is equal to what? Integral tan x sec square x e raised to tan x dx. I'm going to put t as tan x. Then what is the derivative of t? dt by dx is equal to sec square x. dt by dx is equal to 6, so the dx goes to that side, you will get sec square x into dx. So sec square x into dx become dt. So I is equal to integral sec square x into dx become dt, and tan x become t into e raised to t. Here we have to apply partial fraction, sorry, we have to apply integration by parts. What is integration by parts? If there is two functions are multiplied together, you want to integrate that, then what you will do? The first function into integral of second function minus integral of derivative of first function, integral of derivative of first function into integral of second function dx plus c. I'm going to write that equation right here. Listen. Integral of a function into another function. This one is the first function, this one is the second function. Then what you will get? First function into integral of second function minus integral of derivative of first function into integral of second function all dx. And there is an equation, there is a thing I late. Here I is inverse trigonometric function, logarithmic function, algebraic, trigonometric, exponential. Exponential is the last one, so I consider this exponential function as the second function and this one as the first function. Then the answer will be like this: I is equal to first function t into integral of second function, integral of e raised to t, that is e raised to t, minus integral of derivative of t, that is 1, and integral of second function, that is e raised to t, integral e raised to t is in e raised to t, and dt plus c. And I is equal to t e raised to t minus integral of e raised to t plus c. And what is the value of t? What is the value of t? T is tan x. And finally tan x e raised to tan x minus e raised to tan x plus c. Look at here. We can also write I is equal to, you can take the tan x outside. What you will get? E raised to tan x outside. What you will get? Tan x minus 1 plus c. Now you see the RHS of this equation is this. So what you will get? Y e raised to tan x, y e raised to tan x, and integral of this thing will be e raised to tan x into tan x minus 1 plus e. You can divide the entire thing with e raised to tan x. What you will get? You can cancel this e raised to tan x, this e raised to tan x, that there will be an e raised to tan x at the denominator of c. You will get y is equal to tan x minus 1 plus c by e raised to tan x. So you can write that e raised to tan x into c into e raised to negative tan x. That's all. That's your answer. That's all, guys. That's all this chapter. Linear differential equation, homogeneous differential equation, variable separable form. The variable separable form is you can you can interchange the variables to the RHS and LHS and you can integrate. But if you are not able to separate the variables, you can try the homogeneous differential equation. If you can make a particular differential equation in the y by x format, then after putting y by x as v, you can change that particular differential equation into variable form. Then you can separate the variables and integrate it. And the last one, if you can't able to do you can't able to find a differential equation in the format of y by x also, then it should be it must be a linear differential equation, and you can use the equation that I have been told before. And that's all, guys. I think your exam is tomorrow. Yeah, your exam is tomorrow. Hope you'll write it very well, and all the best for your examination. Okay, bye. Thank you.